So in order to talk about some of this stuff with functions, we need to be able to speak the language a little bit. And so we are going to familiarize ourselves with a math term and math notation around this idea of limits, right? And so the goal here is to talk about what is a limit, do they always exist? If you've ever seen the movie Mean Girls, Lindsay Lohan's character has kind of a funny part where she realizes that the limit does not exist. The limit does not exist. So if you haven't seen it, that's probably okay. If you have seen it, we're going to start talking about limits. And perhaps that movie answers the second part of our essential question, which is they don't always exist, and we're going to talk about when they exist and when they don't. So as we get diving in here, let's define kind of some basics with limits, and then we'll look at them more from a math sense. So limits tell us how a function will behave at a certain point or value even if the function does not exist there. In other words, we can start to talk about parts of functions that maybe don't totally exist, but we can talk about the pattern or their behavior. Here's how we do this. We use limit notation. And limit notation looks like this. It says LIM. That's the abbreviation for limit. We talk about the limit as x approaches. That's what the arrow means, is x approaches a number. And we talk about that limit in terms of a specific function. So the limit as x approaches a number in this particular function equals some result. That's the notation you're going to see, and there's kind of some key parts. One is, what number is x approaching? What function are you talking about? And then what is the result? What is that capital L? So we're going to go through and look at two ways of dealing with these limits. The first is we're going to talk about how can we use just regular evaluating to deal with limits. In other words, can we just plug in a number? And the answer is kind of. We can plug in any number we want. The question is, what's the result going to be? So we're going to plug in x. One of three things will happen when we plug in x. If we plug in x and the result is a real number, that gives us our L from that notation we were talking about, which is awesome. That's like the ideal dream situation. We could plug in x and we might get something where we have a number in our numerator divided by 0 in the denominator, but that number in the numerator is not 0. So in other words, we end up dividing by 0. When we have this, we are probably dealing with an asymptote. Not super helpful, but a great time to change to that graphical model to graph your function and see what you can come up with. The third possibility is you might end up with 0 divided by 0. If that happens, try something else. And that's something else, chances are, is what you'll use in calculus when you go and take that down the road. So we're not going to stress too much about this 0 divided by 0. It's maybe a little more than we want to get into. But hopefully when we plug in x, we get one of those results as a real number, and then we can just go forward from there. So that's an option. We can just plug stuff in. However, as we can see, that doesn't work every time. And so sometimes we're going to use a graph to tell us what we want to know about a function and about limits. So we might read a graph. So I'm going to sketch a graph here real speedy like. My graph is going to have 1, 2, 3, 4 lines. The reason I'm being a little bit picky about what your graph looks like, a lot of times I don't stress too much about it, is because I want your answers to match mine so you can feel good about the notes you're taking. So I have 1, 2, 3, 4. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I went out 11. And then I'm going to draw a graph. So I'm going to put a couple key points. I'm going to put a closed circle at 3, 3. I'm going to call it A. I'm going to put an open circle at 3, 1, and I'm going to call it B. And then I'm going to go out to 3, 4, 5, 6, 7. I'm going to put another closed circle right here. We'll call it C. This is what my graph's going to do. I've got kind of two parts to my graph. So my graph is made up of two lines, maybe a piecewise function, if you want to think about that a little bit. And those two lines are going to kind of help us read our graph a little bit. So we're going to talk about 6 limits. I'm going to start with thinking about this limit around when x is 3. So we're keeping in mind kind of what's happening around, right, will behave at a certain point. I'm looking at what is happening when x is 3. So that's kind of what we're thinking about first. So we're going to talk about 3 limits. Here we go. The first is the limit as x approaches 3. But now we're going to approach from the left. So when I put this little negative almost in an exponent spot, it means we approach from the left. So we come from the left side of 3 and we follow the graph. So if I think about approaching 3 from the left, here's what I mean. Here's 3. The left side of 3 is over here. So I'm going to follow the graph. Here's the left side of 3. And I am going to see what is the graph doing on the left side of 3. So I am coming from the left. And I'm going to follow what the graph does. And as I come from the left, the graph is climbing up to A, which has a value of also 3. That's what happens when I approach from the left. The next thing I'm going to do is I'm going to say, what happens when I approach? If I can do it from the left, I can totally do it from the right. And that gets a plus sign. So a plus sign means I approach from the right. So here's 3 again, but here's the right side of 3. And so I'm going to come at 3, but I'm coming from the right-hand side of this. And now my y value, or the value of my graph, is right around 1. So I come from the left, and my graph is headed toward 3 for a y value. If I come from the right, my graph is headed toward 1 from a y value. So all in all, as my graph approaches 3 for this particular function, Lindsay Lohan would tell us the limit does not exist because the two sides don't match. Okay? Now I'm going to show you it with 7, and then we're going to wrap this up and let you practice it a little bit. So the limit as x approaches 7 from the left in this particular function. Well, let's check it out. Here's 7. Here's the left side of 7. I'm coming from the left. When I do that, my function equals 3. If I approach 7 from the right, here's 7, here's the right, once again, my function equals 3. So that means the limit as x approaches 7 for this particular function, right? I should probably clarify. This function right here, this is my f of x. The limit as I go to 7 is 3, no matter what, because both limits match. Now I know that this is kind of new and unfamiliar.